We are about to explore acids and bases through a problem-based learning scenario. What do you know about Gerdy's dilemma? You're about to find out. So Gerdy has been so nervous. With summer coming upon us, his anxiety just won't allow him to get much rest. He even had a panic attack. Instead of self-treating, Gerdy did what you're supposed to do. He went to see a psychiatrist. The psychiatrist prescribed him lorazepam. Now, instead of insomnia, Gerdy is sleeping through the night and is less anxious during the day. His focus has increased tremendously. Gerdy was able to apply for several summer research opportunities, and now he has an interview. It is the week before the interview, and now Gerdy has consistent heartburn. He thought it was because he ate pizza one night studying, but it has persisted, and it's been more than 2 nights. Gerdy really must consider taking something over the counter, but he's not sure which antacid would help him. Can you help Gerdy find out which antacid would be the most effective so that he won't have to add any more medications to his already increasing health concerns? Let's see what we can do for Gerdy. So many choices, 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 choices. You can determine which antacid Gerdy should use if he doesn't want to contend with flatulence also during his interview for his summer program. So you have so many choices: Tums, Alka-Seltzer, Phillips, Milk of Magnesia, Gaviscon, baking soda. There are so many antacids on the market. Which one should Gerdy use? So what are antacids? Antacids like calcium hydroxide, magnesium hydroxide, aluminum hydroxide, sodium bicarbonate, and sodium carbonate are weak bases, which are typically found as the active ingredient in most antacid remedies. Stronger bases like sodium hydroxide and potassium hydroxide are very harmful to the body, and they are strong bases and can cause corrosion if they're swallowed. So weak bases are used to neutralize the excess hydrochloric acid that is in the stomach. And this excess of hydrochloric acid can be caused by overeating. It can be certain foods, whether they're spicy or have certain flavors. They could be medications that you take to treat depression, anxiety. It could be pregnancy because of a woman's growing body, or obesity can all stress the stomach sphincter leading to the esophagus. And so stomach acid is necessary to digest food and keep the bacteria from overgrowing in your stomach. It also provides the optimal pH for digestive enzymes to be activated to further digest your food. However, when there's excess acid production over long periods of time, people usually end up with a diagnosis of gastrointestinal esophageal reflux disease, or GERD. That may be Gerdy's culprit. Here are calcium, magnesium, and aluminum-based antacid reactions. So you have calcium hydroxide that reacts with 2 moles of hydrochloric acid to give you calcium chloride and water. You also have magnesium hydroxide that reacts with 2 moles of hydrochloric acid to give you magnesium chloride and water. Aluminum hydroxide reacts with 3 moles of hydrochloric acid and gives you aluminum chloride and water as well. And here's just another representation using ball and stick figures so you can actually see the 3D um, orientation of calcium hydroxide reacting with hydrochloric acid and forming this calcium chloride in water. Same thing here with magnesium hydroxide with hydrochloric acid forming magnesium chloride in water. And then we have aluminum hydroxide plus our hydrochloric acid leading to aluminum chloride and water. So we also have carbonate-based antacids like sodium carbonate and sodium bicarbonate, which is baking soda. So sodium carbonate reacts with 2 moles of hydrochloric acid to give us sodium chloride. We get carbon dioxide and we get water. Same thing here. Sodium bicarbonate reacting with hydrochloric acid to give us sodium chloride. We have water and we also have our carbon dioxide. This is just another representation of the reactions happening. Sodium carbonate with hydrochloric acid leading to sodium chloride, carbon dioxide, and water. And then our sodium bicarbonate leading to with hydrochloric acid leading to sodium chloride, carbon dioxide, and water as well. So how do you compare effectiveness? Compare the effectiveness of 1 gram of sodium bicarbonate, which is baking soda, to 0.5 grams of magnesium hydroxide, which is found in milk of magnesia, in combating the acidity in the stomach. What do? How do you calculate this? So you have the equations with sodium bicarbonate. You have the equations also with magnesium hydroxide and hydrochloric acid. And so you must look at what's called stoichiometry. We solve the problem. We change grams to moles using the molecular mass of the antacid. Make sure that the chemical equation is correct and balanced. You're going to stoichiometrically determine how much HCl will be neutralized based on the number of moles of antacid that you have. After that, you can determine which one will react with a greater amount of hydrochloric acid. What things do you need? You need to find the molar mass of sodium bicarbonate. You definitely need to find the molar mass of magnesium hydroxide. After you do that, you're going to do a little math calculation, but you are looking at the balanced equation to get your final answer. So in order to calculate the number of moles, you need to take the grams that I gave you in the beginning and multiply that by the inverse of the molar mass, moles per gram. And then you do the math. So here are the balanced equations right here. And after you determine what the molar masses are, you convert those grams into moles. For sodium bicarbonate, we get 1.19 times 10 to the negative second moles. For magnesium hydroxide, we get 8.57 times 10 to the negative 3 moles. The stoichiometry is that for 1 sodium bicarbonate mole, you have 1 mole of HCl. But for 1 magnesium hydroxide, you have 2 hydrochloric acids. And so you can use the stoichiometric ratios in order to determine how much acid can be neutralized. So if you have 1.19 times 10 to the negative 2 moles of sodium bicarbonate, then that means that you also have an equal amount of moles of HCl, 1.19 times 10 to the negative 2. If you have 8.57 times 10 to the negative third moles of magnesium hydroxide, then you also have 2, because it's 2 hydrochloric acid, 2 moles. So 2 moles of hydrochloric acid times 8.57 times 10 to the negative 3 moles will give you 1.71 times 10 to the negative 2 moles of HCl. And so magnesium neutralizes a greater amount of hydrochloric acid and thus should be more effective. That was easy, right? I thought so. So what are your tasks? You must discuss the procedure for determining the most effective antacid based on the active ingredient amounts. So you're going to get together in groups. You're going to develop a lab experiment to help prove that your calculations are correct. This is Advanced Inorganic Chemistry Lab, and so you have to develop your own lab experiment. After that, you're going to record a 3-minute video of you explaining your experiment, and you're going to post it to Blackboard. And I mean 3 minutes. You should be able to explain how you're going to go through your lab experiment by just telling us the key points in 3 minutes. And then you're going to upload the written experimental protocol with all the details, as well as your hypothesis for which one you thought will work the best to Blackboard. So these are your values, and this PowerPoint will be available for you in your Blackboard classroom under content. So your values are that you have 1.25 grams of sodium bicarbonate, 0.75 grams of sodium carbonate, 2 grams of aluminum hydroxide, 0.5 grams of magnesium hydroxide, and 2 grams of calcium hydroxide. Which dosage of antacid will be the most effective for Gerdy? Now remember, he doesn't want to deal with the flatulence either afterwards. What course of action should he take? Again, these are your tasks. So now that you know all of the amounts and the dosages that Gerdy has to look through on these bottles to figure out which one is going to be the best, you can discuss your procedure, develop your lab experiment, record your 3-minute video and upload it, and make sure that the written experimental protocol that came from you developing your lab experiment is also there. Something else that you just might want to think on. Some antacids contain what we call alginates, and they're found to be substances that produce a neutralizing layer that prevents acid from rising back into the esophagus and prevents heartburn. They kind of float on top of the stomach acid like a raft and are really protective. Some antacid formulations also add dimethicone as an anti-foaming agent to prevent bloating and flatulence. Which active ingredient do you think this is most necessary for?